Hey, what's up, everybody? So this is the key for the Horizontal Projectile Lab from last week. So a couple key things keep coming up as I'm looking through them. But I'll go over the pre-lab questions here, which are most kids did pretty well on. We went over them in class. But so we have a projectile launched horizontally. That means it has no vertical motion. So some people said upward, but we just mean straight horizontal means there's nothing in the vertical plane. And then that changes immediately due to the force of gravity accelerating it in the downward direction. So because that force is on it, it accelerates downward, so it's no longer just moving horizontally. And which component of the velocity changes in the air? So that's the vertical component. And then we talked about the horizontal component stays constant. So we did that demo last week with the one that fell straight down and the one that gets shot out to the side. We saw the independence of those, and we talked about a lot of these concepts. So initial vertical velocity is just 0 meters per second because it, just like when we had an object in free fall, it's just going to drop straight down. It's going to accelerate, but it starts at 0 when it comes flying off the table or whatever it was. And if you know the vertical height, what formula do we calculate the time to fall or time in the air? So that's the time equals the square root of 2d over a. And most kids got that. I had a few who missed it, but then as we talk through it, there's some application of that we got to make sure that we're doing. So one of the things that you're going to want to do, I've got someone's data in here that looked like they did a pretty good job. So you're going to want to check your data and look for either things that I was able to catch or proof it yourself. But what should happen is these 3 times should be the same. And that's because the ball falls from the same table each time. So the vertical height was the same each time. Now, the distance they travel was not the same. So you can see this person's, it went 0.16 meters, then 0.23, and then 0.33. So that increases each time, and that's because we changed the height of the ramp that we rolled the ball off of. So as we changed the ramp height, the ball was going faster along the table, and the faster it leaves the table, the further over it's going to land. And we talked about that in class as well. So hopefully that makes sense. But I saw some people whose data didn't make sense, so you're going to want to go back and look at that. I also had some people, they calculated the time wrong here. So that would definitely mess it up. And you just use that formula that we just did in the pre-lab questions. So in terms of the range, these 3 numbers here go right here in your lab data. Initial vertical velocity, 0. We talked about that from the pre-lab questions. And then to figure out the horizontal velocity. So you remember this doesn't change the whole time it's in the air. So whatever this column is should match up with this column. And so that's one thing I looked at when I checked them over is did those match? And if they did, then I knew that you did that part right. And where this comes from is to get the horizontal velocity, we looked at the distance it went horizontally divided by the time in the air. So 0.16 divided by 0.42 comes out to be 0.4. And so this person, it looks like they did those correctly. And then the final vertical velocity. So to get that, we do acceleration times time. These were in the air for 0.42 seconds. So we multiply that by 10 to get 4.2. And these 3 should be the same, because if this is the same, these are the same. So that's an important thing that you can understand. Which of these is the correct side view of the projectile? So I think everybody except for maybe one person that I saw said the one on the right here. So this one, however you said that, and explain what causes that path. Is that the ball's vertical velocity increases as it flies through the air. So that's one way of saying it. There's lots of different ways to get that same point across, but the vertical component of its velocity is going to change, which means it's going to fall more and more distance each second. So that would give us this parabolic path. Here's what we talked about a minute or so ago, explain why raising the angle of the ramp affects the range. And so that's the higher the ramp, the more the ball accelerates and then has a higher velocity. This causes the ball to land further away from the table. So increases the range. And most kids seem to understand that, so that was good. Here, if you used a table that was 0.9 meters high, how long would the ball be in the air? So you just had to use that formula. Time equals square root of 2d divided by a. And here's what I saw. Some kids, they put acceleration in wrong as we went through here. So you just got to make sure you're doing that correctly. So square root 2 times 0.9, and divided by 10. So that gives you 1.8 divided by 10. So square root of 0.18, which if I remember right was 0.42 seconds. All right, I just went in and filled some stuff in on here. So this was 0.42 seconds. And then we had this problem here. So this one, there were a couple problems that I noticed kids made when they went through it. Some people are screwing up what goes in here. And so we want to make sure that, the distance is the vertical distance is what determines the time in the air. So here you'd make sure you'd use the 1.5 meters for this distance right here. And then acceleration is 10 meters per second squared. So when you do that, then you get 0.55 seconds as your answer. How far from the table? So some different answers there. Kids were dividing and stuff like that. So I put this formula here, same from the notes in class last week. So to find the horizontal distance, we do the horizontal velocity times the time. So horizontal velocity, which remains constant while it's in the air, is right here. Multiply that by the time we figured out right here, and you get 1.93. Final vertical velocity, Vy, do acceleration times time, so 10 times the 0.55 seconds, 5.5 meters per second. And the final horizontal velocity, so kids were doing a lot of math on this, and we talked about in class, but if you missed it, you don't have to do any math here because you just got to know conceptually that the horizontal velocity stays constant. So if it leaves the table at 3.5 meters per second, then the final horizontal velocity is 3.5 meters per second. Some of you proved that math-wise. I'm not sure if you realized it because of rounding. You had, like, kids were giving me like 3.48, stuff like that. Really, you just found this again, and you didn't have to do any math to do that. So here, this chart seemed to be either simple or confusing, depending on your approach to it. So when we think about the horizontal motion, there are no forces horizontally. So that causes, if there's no forces, it causes no acceleration. Just like balanced forces would be no acceleration. And that means if there's no acceleration, that velocity is constant. And so we know that the horizontal velocity is constant the whole time. But vertical motion, we have the force of gravity, and that's downward. And so that does cause things to accelerate in the downward direction, and we all know that. And then that means that the velocity must be changing because it's accelerating. And that's a really key thing for you to realize about the projectile motion. Constant horizontal velocity, accelerating downward velocity. So as we go through this, I put the answer to this was on the notes from last Thursday or Friday. So I'm not going to put all the answers up here, but make sure you pay attention to what you did in terms of the force vectors. And this, I noticed this today with what we did with the free body diagrams. So just make sure when thinking about the force on the ball as it flies through the air, the only force is the force of gravity. So some of you labeled velocities and accelerations, which is great that you know those, but they don't apply to this question right here. And so just make sure that you have looked at this from the notes. I'll actually put the answers in the key itself, but I'm just not going to talk through them because we did that in class. And remember, we changed this last question to the horizontal and vertical. So I'll make sure I edit that. So in the key that I post, it's got the answers for this.